Hello students, welcome to the second lesson of the Abacus course. Our main focus today is learning to master single-digit subtraction and addition. But first, let's recap what we have learned from the last lesson. So please take around 10 seconds to figure out the number displayed below. Alright, this number is 15,734. Do remember to read the abacus from left to right. We can see that there is a value of 1 in the 10,000s place, a value of 5 in the thousands place, a value of 7 in the hundreds place, a value of 3 in the tens place, and a value of 4 in the ones place. When counting the beads that are touching the crossbar, do take note to look at both the upper layer and the bottom layer of the abacus. Next, can you tell what number is displayed below? I'll give you 10 seconds. If your answer is 26819 or 26,819, you are correct. There is a value of 2 in the 10,000s place, a value of 6 in the thousands place, a value of 8 in the hundreds place, a value of 1 in the tens place, and a value of 9 in the ones place. Lastly, please figure out what the last abacus is showing. This abacus is showing a value of 90,507. Do note that in the thousands and tens place, there are no beads touching the crossbar. This means that the number displayed in the thousands and tens column is 0. However, we must still count these zeros as part of the number 90,507. This is because the zeros are in between non-zero digits like 9, 5, and 7. There are zeros that are important or significant to the whole number. When the zeros are on the left of the first non-zero digit, then there are zeros that are not important to the number and we don't count those zeros. And that's it for the segment on identifying numbers. If you need more practice on this topic, please consult your tutor for additional worksheets. In this lesson, we will be learning about fingerings and basic addition and subtraction with the abacus. So why are fingerings important? Why can't we just use an abacus simulator? So fingerings are used on a physical abacus and they help us develop muscle memory on the abacus. So instead of using an abacus simulator like the last lesson, using a physical abacus will help train our calculation speed and is also the prerequisite for mental arithmetic. First, let's learn how to set single-digit numbers on the abacus. Make sure to clear your abacus to the default position before doing a new sum like this. If I want to set 1 on my abacus, I can push out 1 bead using my thumb. Similarly, to set 2 on the abacus, I can push up 2 beads using my same thumb. To set 3, I push up 3 beads, and to set 4, I push out 4 beads. Now to set 5 on the abacus, I can push down 1 5 bead using my index finger, because like we learned last lesson, we don't have enough 1 beads to set 5 just using the bottom row beads. So for the number 6 to the number 9, things get slightly more complicated. I have to push down the 5 bead and push up enough 1 beads at the same time. This can be done with a pinching motion, which I'll showcase in a while. For the number 10, I simply need to push out 1 of the 1 beads. But this may be a little bit confusing, which is why I'm going to demonstrate this in a while. Do note that I do not need to push the beads one by one. I can push multiple beads up at the same time by putting my thumb below the bottom bead. I'll demonstrate this now. Okay, so as you can see right here, my abacus is a bit messy, so the beads are scattered everywhere. This is why it is important to reset the abacus to the default value of 0. Let me show you how to do this. First, to clean the abacus, pinch the crossbar like this on one end, and then slide your hand across the entire abacus. This will push all the 5 beads up and all the 1 beads down. Now that the abacus is cleared, this has provided us with a clean abacus to do our calculations. I will show you now how to set the numbers 1 to 10 on the abacus. I will start on this column with a dot over here. then move to the right every time we finish setting a number. To set 1, I can push up 1 beat. To set 2, 2 1 beats are pushed up. To set 3, 3 1 beats are pushed up. And to set 4 on the abacus, I push up 4 1 beats. Notice how I use my right thumb to add the 1 beats. Next, I am going to set 5 by pushing 1 5 beat down using my right index finger. For the numbers 6, 7, 8 and 9, remember that they are made up of 1 5 beat and several 1 beats. For these numbers, I don't need to push the beats one by one either. I can simply pinch the top and bottom beats to set the number in a more efficient way. For example, the number 6 requires me to push down 1 5 beat and push up 1 1 beat. Therefore, I'll place my fingers like this and move both beats down to the crossbar at the same time. Let me demonstrate again. There, a pinching motion. A similar action is done for 7. 7 is made out of 1 5 beat and 2 1 beats. Therefore, I place my fingers like this and I pinch downwards like this. As for 8, here is how the pinching is done. 8 is made out of 5 and 3, so I can push up 3 1 beats and 1 5 beat. Lastly, to get a value of 9, I push up 4 1 beats and I push up 1 5 beat. And it can be done in one swift motion. There you go. This is the pinching motion. Now let me clear the abacus and let me show you how the number 10 can be set. If you recall the last lesson, the number 10 also has a 1 beat, but it is in a different column because the value 1 is now in the tens place and not the ones place. Therefore, I can simply use my thumb to push out the 1 beat in a different column. So let's say this is the ones column and this is the tens column. This number here is the number 10. Now, let's learn how to remove numbers. This is known as subtraction. Remember how I used my right thumb to push up the 1 beat to set the number 1? Now, I must use the right index finger to push the 1 beat back down. Again, here's the number 1 and here's removing the number 1 using my right index finger. Now I have a value of 0. This same action can be done for 2, like this, minus 2, 3, and then minus 3, and then 4. I take away 4 beats at the same time. When I have the sum 2 minus 2, I simply remove 1, 2 beats from the column. However, I do it in one swift motion like this. Same thing for the number 3. I don't do this, removing 1 beats one at a time. I simply push all the 3 beats down. And 4 minus 4 is simply pushing 4 beats down at the same time. So the index finger is placed just below the crossbar over here. For example, if I want minus 3, I put my finger over here and I push down. The index finger is placed just below the crossbar so that it can push all the beats down at once. Next, I also have to use my index finger to remove the 5 beat on top, like this. Using my right index finger, I flick the 5 beat on top, like this, to remove the 5 beat. Now, this abacus has a value of 0. For the numbers 6, 7, 8 and 9, I need to pinch my hand together near the crossbar, and then after that, move it near the crossbar and push the 5 and 1 beat away. But there's a more efficient method. I can split the 6 open like this. Same goes for the 7, the 8 and the 9. Please watch again. 6 is made out of 1 5 beat and 1 1 beat, and I can split it open. 7, 8 and 9. So basically this is the reverse of pinching. We call this splitting. Next, for the number 10, it is just like removing the number 1. To do 10 minus 10, I use my index finger to push the 1 down. So now I'm going to show you how to do even more complicated sums. The first sum is 1 plus 1. As you can see, I just move up 2 1 beats. The first thing to do is actually to set up 1 on the column over here, and then I have to add 1 to this existing column. So therefore, to add 1, I have to push up one of the 1 beats like this. I see that I have a total of 2 1 beats. Let me re-demonstrate my finger rings. To set up 1 on the abacus, I use my thumb to push up 1 beat. And then after that, to add 1, I use my thumb to push up another 1 beat. So the answer I get is 2. Next, I have 1 plus 2. I will first set the number 1 on the abacus. And then to add 2, I see these two 1 beats and I push them up. So notice how I use my thumb to push up both of the 1 beats at the same time instead of adding them one by one like this. So that's very time consuming. I can just add 2 by holding the bottom of the second beat over here and then just pushing them up. Very easy. The answer I'll get is 3. Next sum, 1 plus 3. After I set the number 1 on the abacus, I have to add the number 3. So very simply, I push up 3 1 beats and then I'll get the answer 4. Next sum, starting with 2. 2 plus 1. So this may sound very similar to 1 plus 2, but it has its own very different set of finger rings and steps. First, I start off with the number 2, and then after that, I need to add 1 to the number 2. So I push up 1 beat, like this. And then I'll get the answer of 3. Next sum, 2 plus 2. 2 plus 2 is basically just setting 2 on the abacus over here and then adding 2 1 beats like this. Next sum, 3 plus 1. I set 3 on the abacus and then I add 1 beat over here. I get a value of 4. Actually notice that I'm not going to numbers above 5. So that is where addition gets a little more complicated. Therefore, let's master subtraction from the numbers 0 to 4 first. Firstly, I have 4 over here, 4 minus 1. To minus 1, I use my right index finger to push the 1 beat down. Again, I use my right index finger to push the 1 beat down. So recall that adding 1 is actually pushing up a 1 beat. So therefore we can go by the reverse logic when subtracting. And adding 1, since adding 1 is pushing up, subtracting 1 is naturally pushing down. Let me set up the number 4 here. Just to demonstrate again, to remove 1, I just use my index finger to lightly push 1 beat downwards. I get the number 3. So how about 4 minus 2? I set the number 4 up. When I add 2, I push 2 1 beats up. So when I subtract 2, I have to push 2 1 beats down like this. And I get the answer of 2. 4 minus 3 has a similar set of finger rings. I set 4 up on the abacus and I push 3 1 beats down. I get an answer of 1. So back to the slides. Here are the detailed finger rings that I've used just now. You can pause the video and try it for yourself. So now, we will be going through some examples in the worksheet. Please pause the video and try these 10 questions. So these are the answers to the small exercise. If you got less than 7 questions correct, you are advised to try the questions again. It is okay to refer to the finger rings in front should you be stuck. Just rewind the video to do that. Before we move on to larger numbers, let's learn about complementary numbers. Complementary numbers are any pair of numbers that add up to either 5, 10, 100, 1000 and so on. For example, 1 and 4 are complementary numbers that add up to 5. 2 and 3 are also complementary numbers. We can see that complementary numbers add up to their respective whole no matter how you order them. For example, there is no difference between 1 plus 4 and 4 plus 1. Similarly, there is no difference between 2 plus 3 and 3 plus 2. They both add up to the number 5. While we are learning about 5, it is also good to learn about numbers that the number 5 is part of. For example, 6 is 5 plus 1, 7 is 5 plus 2, 8 is 5 plus 3, and 9 is 5 plus 4. This information is quite important for future calculations. Let's look at several example questions and try to apply what we have learned about complementary numbers. The first example, 5 minus 3 equals to 2. We know that there are not enough 1 beats to display the number 5. Therefore, to subtract 3, we cannot simply remove 3 1 beats because in the number 5, we don't use any 1 beats at all. Therefore, let's use the concept of complementary numbers to solve this problem. 5 is made out of 3 and 2. So following this logic, subtracting 5 is basically taking away 2 more than subtracting 3. In other words, if I minus 5 first, then return the extra 2 that I've subtracted, I'll get the same result as if I minus 3. As you can see in example 1, we can manipulate 5 minus 3 into 5 minus 5 plus 2 to make the calculation possible. 5 minus 5 is 0, and then 0 plus 2 gives us the answer 2. For the next example, example 2, we have 8 minus 4. We realize that there aren't enough 1 bits to subtract. There are only 3 1 bits in the number 8. So therefore, we have to make use of the concept of complementary numbers again. We can manipulate minus 4 into minus 5 plus 1. This is because I am originally supposed to minus 4, but I have subtracted too many by removing the 5 bit. So essentially I'm removing 5. I need to make up for it by adding 1 to the number that I got by doing that. 1 minus 5 is minus 4. So therefore, 8 minus 4 can be manipulated to become 8 minus 5 plus 1, which is 4. So for example 3, I have to add 4 to the number 2. Again, realize that adding the number 4 is equal to adding the number 5 and then subtracting 1. 4 equals to 5 minus 1. So therefore, I take the number 2 and I add a 5 bit to it. Then I realize I've added too much. The question wants me to add 4, but I've added 5. Therefore, I remove 1 from the number I got after adding 5. I can do this by removing a 1 bit, and that gives us the answer of 6. The last question wants us to add number 1 to the number 4. Similarly, we can convert 1 to plus 5 and then minus 4 after that. Thus, we can add a 5 bit to 4, and then after we realize that we added too much, we subtract the 4 extra that we have added to give us a value of 5. Next, I'm going to talk a little about the fingerings of calculations with the number 5. If I take 5 and then subtract it by 5 to get an answer of 0, I use my index finger to add and then subtract the 5 bit. 5 minus 4 will give us a value of 1. We can solve this by removing a 5 bit and adding a 1 bit, as I've explained just now. 5 minus 3 equals to 2. We push out one 5 bit using our index finger, and then we push out two 1 bits using our thumb at the same time to get an answer of 2. Next, 5 minus 2 gives us a value of 3. I use my index to push away the 5 bit and then add 3 1 bits. Lastly, 5 minus 1. 5 minus 1 gives us 4. I push away one 5 bit and then I proceed to add 4 1 bits. Next up, instead of subtraction, we are going to add numbers to give us the number 5. 1 plus 4 is 5. Adding 4 is basically adding 5 and then subtracting the number by 1. 1 plus 4 equals to 1 plus 5 minus 1 equals to 5. Because by adding 5, we've added 1 more than we were originally supposed to. 2 plus 3 gives us 5 too. To the number 2, we add 5 and then remove the number 2. Adding 3 is basically adding 5 and then subtracting 2. 2 plus 3 equals to 2 plus 5 minus 2, which is equals to 5. This is because the question wants us to plus 3, but we have accidentally plus 5 because there are not enough 1 bits for us to add. Therefore, by adding 5, we need to remove the extra that we have added in. And what is the extra here? The extra is 5 minus 3 equals to 2. We have added 2 1 bits extra in addition to the 3 1 bits. And therefore, after we add 5, we must minus 2 to compensate for the additional addition. Next, 4 plus 1 is simply 4 plus 5 and then minus 4. Plus 5 minus 4 is basically plus 1. Lastly, 3 plus 2 is actually just 3 plus 5 minus 3. 3 plus 5 minus 3 gives us a value of 5. Now, let me show you how to do the fingering for these sums. In this segment, I will be going through sums pertaining to the number 5. So firstly, I have 5 minus 5. Let me set 5 out on the abacus, and then after that I remove 5 using my index finger. Again, set 5 using my index finger, and then remove 5. Pretty easy. For 5 minus 4, I first set up 5, and then I recall that I have to use the concept of complementary numbers. So minus 4 is actually minus 5 plus 1. Again, 5 minus 4 is equals to 5 minus 5 plus 1. Minus 5 plus 1. Like this. I can actually do this in a quicker motion, and this is what we are trying to achieve. So when I do 5 minus 4, I quickly push up the 5 bit and then push up the 1 bit at the same time. I'll show you again. 5 minus 4. 5 minus 4. You can practice this with the other sums as well. For example, I have 5 minus 3. 5 minus 3 is basically minus 5 plus 2. Minus 5 plus 2. And over here, I can do this sum pretty quickly if I combine both of these movements together. 5 minus 3, you get 2. 5 minus 3, you get 2. Again, with 5 minus 2, it's basically the same set of finger rings. 5 minus 3, 5 minus 2, you get 3. 5 minus 5 plus 3, 5 minus 3, over here. And then after that, we have 5 minus 1. 5 minus 1 is minus 5 plus 4. So we have 5 minus 5 plus 4. 5 minus 1. 5 minus 1. Pretty easy. Next, we have addition. 1 plus 4 is basically 1 plus 5 minus 1, which gives us 5. So we can conclude that 1 plus 4 is basically 5. And we can do this. Combine both of the movements together. Again, 1 plus 4 is 5. 1 plus 5 minus 1 is basically 1 plus 5. Next, we have 2 plus 3. Over here I set up 2, and then after that I recognize that plus 3 is basically plus 5 minus 2. Plus 5 minus 2. Like this. So 2 plus 3 is basically 5. Notice how when my pinch moves down, I'm adding 5 over here and then I'm subtracting 2. So like this. 2 plus 3 is 5. Same concept. 3 plus 2. I set up 3 first, and then I add 2 like this. 4 plus 1. I set up 4, and I add 1 like this. Because 4 plus 1 is basically 4 plus 5 minus 4. So I do this, 4 plus 5 minus 4. Pretty easy. So that concludes the segment on counting up to 5. Now, we will be dealing with larger numbers like 6, 7, 8, and 9. So in this example, we have the sum 1 plus 6. 6 is the sum of 5 and 1. So if I add 6 to a number, I'm basically adding 5 and 1 to the number at the same time. On the abacus, I'll push down 1 5 bit and push up 1 1 bit. Therefore, 1 plus 6 is equals to 1 plus 5 and then plus 1 again, which gives us 7. Next, we have the sum 9 minus 7. 7 is the sum of 5 and 2. So let's say I subtract 7 from a number. I'm basically removing 5 and then removing 2 from the number at the same time. On the abacus, I'll remove 1 5 bit and 2 1 bits. Therefore, 9 minus 7 is equal to 9 minus 5 and minus 2 again, which gives us 2. Lastly, we have the sum 3 plus 6. 6 is basically 5 plus 1. 3 plus 6 is 3 plus 5 plus 1, which is 9. I move 1 5 bit and 1 1 bit because of 6. Lastly, let's move on to even larger numbers like 10. I can also make use of complementary numbers with 10. 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, and 5 plus 5 all give me a value of 10. So in this case, I can say that 1 and 9 are complementary numbers. Do note that complementary numbers can add up both ways. So this means that no matter where I place them in the number statement, I will definitely get a value of 10. For example, 1 plus 9 is 9 plus 1, and 2 plus 8 is equals to 8 plus 2, like I mentioned before with the case of 5. Now let's do several example questions. So in this slide, look out for the numbers highlighted in red. They add up to the number 10 and are complementary numbers. So for example, in example 1, 10 minus 1 is the same as 10 minus 10 and then plus 9. I am supposed to take away 1, but by taking away 10, I remove 9 more than I'm supposed to. So this gives us a value of 1. Therefore, I compensate back by adding 9. So this is called borrowing. It's similar to what you do in vertical subtraction. In this case, the numbers highlighted in red, namely 1 and 9, add up to the number 10. So I cannot simply minus 1 from the value 10 as seen in the picture, because in the ones column, there are no 1 bits for me to take away. So I have to take away tens, then compensate back by adding ones. In example 2, 10 minus 8 gives us 2. And removing 8 is the same as removing 10 and then compensating back by adding 2, because I have subtracted too much. Therefore, 10 minus 8 is equals to 10 minus 10, which gives us 0, and then adding back 2 again, which gives us the final answer of 2. So in example 3, 10 minus 7 equals to 3. In this sum, I remove 7 from the number 10. I can use the same method as shown previously. I don't have enough bits in the ones column, therefore I have to deal with the tens column first. To make do, I subtract 10 away from the current 10. So 10 minus 7 is basically equals to 10 minus 10 plus 3. After I subtract 10 away, I realize I subtracted too much and I have to add 3 to compensate for how much I subtracted. In example 4, we can use the same method to solve this problem. 10 minus 4 is equal to 6. 10 minus 4 is the same as 10 minus 10 plus 6. I have subtracted 6 more than I was supposed to, so I must add it back. This will give me an answer of 6. Now that we are done with subtraction, let's move on to addition. Example 5. 1 plus 9 is 10. We do not have enough bits in the ones column to add 9 to the number 1. There is simply too many bits in the number 9. So therefore, we have to expand plus 9 into plus 10 and then subtracting 1 from there. So plus 9 equals to plus 10 minus 1. Because by adding 10, we are basically adding 1 more than we are supposed to. So we have to subtract 1 from that to get a total change of plus 9. When I add 10, like I mentioned just now, I've added 1 more than I was supposed to. So therefore, I have to subtract that extra 1 off. 1 plus 9 is equals to 1 plus 10, but then I have to minus 1. So 1 plus 9 equals to 1 plus 10 minus 1, which gives us a value of 10 in total. So for example 6, we have 7 plus 3 equals to 10. Similar to the last example, we only have 2 1 bits left in the ones column. Therefore, we somehow need to work with the tens column. So to do that, we add the number 10 and then subtract it by 7. This is because plus 3 equals to plus 10 minus 7. By doing that, we are effectively adding 3. So this gives us the answer of 10. Example 7. 9 plus 1 equals to 10. Adding 1 is equals to adding 10 and then subtracting by 9. This is because when I add 10, I added 9 too much. I'm supposed to add 1 but I added 10 instead, so I must subtract 9 to get rid of the extra that I've added. After that, we get a value of 19, and then after minusing 9, we get a value of 10. For example 8, 5 plus 5 is equals to 10. Similarly, I do not have enough 1 bits to add to the number 5. Therefore, I must add 10 first and then somehow compensate and remove the extra. 5 plus 5 is the same as 5 plus 10 and then I remove the extra, which is 5. So plus 5 is equals to plus 10 minus 5. I remove the extra of 5. In this segment, we will be exploring the fingerings of even more sums. To keep it simple, they will be within 10. So firstly, we have 1 plus 5. In this column, the ones column, I add 1 and then I add a 5. 1 plus 5 is 6. Easy. After that, we have 2 plus 5. I set up 2 and then add 5. We get 7. What about 3 plus 5? 3 plus 5 is simply 3 plus 5. And then after that, 4 plus 5, over here, we get 9. Simple. Second set of sums, 5 plus 1. So let me set up 5 over here, and then I add 1, using my right thumb. 5 plus 1 is 6. Next, 5 plus 2. I set up a 5, and I add a 2 to it. I get 7. Next one, 5 plus 3. 5 plus 3. I get 8. Next one, 5 plus 4. I get a 9. Easy. And then after that, 6 minus 1. 6 minus 1. Using my index finger, I push down 1 beat. 6 minus 1 is 5. 7 minus 1. I set out a 7, and then I minus 1 using my index finger. 7 minus 1 is 6. After that, I have 8 minus 1. 8 minus 1 is 7. 9 minus 1 is 8. Next set, 7 minus 2. 7, I take away 2 beats, minus 2, I get 5. 8 minus 2, I get 6. 9 minus 2, I get 7. Next set, 8 minus 3. To remove 3, I simply push down 3 1 beats. 8 minus 3 is 5. I'll show you again. 8 minus 3 is 5. 9 minus 3 is 6. So moving on to the next set, we have 9 minus 4. So I set up 9 over here, and I push down 4 1 beats to get 1 5 beat on top. Next set, I have 6 minus 5. This is also rather easy. I just push up 1 5 beat to get 1. 6 minus 5 is 1. I have 7 minus 5 is 2. How about 8 minus 5? And it gives us 3. 9 minus 5 gives us 4. Next set, 1 plus 6 gives us 7. Notice how 1 plus 6 involves me pinching a 5 beat over here and a 1 beat over here up at the same time. Again, 1 plus 5 plus 1, 1 plus 6 is 7. Moving on, 2 plus 6. Same thing, I set up a 2 and I push down 1 5 beat and I push up 1 1 beat. In one swift motion, 2 plus 6 is 8. Next, 3 plus 6. It's the same thing, but I set up a 3 instead. 1 5 and 1 1 beat. Together, they form 6, and the answer is 9. Next set, 1 plus 7. I set up 1 and I push up a 7, which comprises 1 5 beat and 2 1 beats over here. 2 1 beats and 1 5 beat. So I push up 5, I push down 5 and I push up 1, which forms 7, and my final answer is 8. Next, 2 plus 7. 2 plus 5 plus 2 gives us 9. Again, 2 plus 7 is 2 plus 5 plus 2 gives us 9. In one swift motion, 2 plus 7 is 9. 1 plus 8. 1 plus 8 is basically 1 plus 5 plus 3. So it involves 1 5 beat and 3 1 beats over here. So 1 plus 8, I pinch everything together to form 9. So next, I have 9 minus 9. 9 over here, using my pinch, I split it open like that. 9 minus 9, minus 5 and minus 4. I minus everything in the column basically. So 9 minus 9 is 0. Next, I have 9 minus 8. 9 minus 8 is slightly more complicated. Minus 8 is basically minus 5 and then minus 3. Because this is our 8, right? And then to minus 8, we need to take off the same amount, which is 3 1 beats and 1 5 beat to get 1. So this is 9 minus 8. How about 9 minus 7? This is 7, made out of 1 5 beat and 2 1 beats. So 9 minus 7 is 1 5 beat, 2 1 beats, 2. Again, 9 minus 7, I split it open like that. Okay, lastly I have 9 minus 6, minus 5, minus 1. Because 6 is comprised of 5 and 1. So 9 minus 6 is 3. Again, I split it open like that. Okay, next I have 8 minus 8. 8 minus 8, I split everything open. Minus 5 minus 3. I use my thumb for the minus 3 and my index for the minus 5. So split open, 8 minus 8. Next one, 8 minus 7. 8 minus 7 is basically the same as 8 minus 8, but I remove 1 less 1 bit. Over here, I minus 5 and I minus 2, but I keep 1 bit over here. Take note of the finger ring. As usual, I split this open, and then I'm left with 1. How about 8 minus 7? Sorry, 8 minus 6. 8 minus 6 is quite simple as well. I push up 1 5 bit and I push down 1 bit. It like this. 8 minus 6. Next, I have 7 minus 7. So this is a 7, I set up a 7 over here. Minus 7 involves me pushing everything apart, because 7 minus 5 minus 2 gives us a 0. So 7 minus 7 is 0. Next, I have 7 minus 6. 7 minus 6. In minus 6, I have a minus 5 and a minus 1, because 6 is made out of 5 and 1. So 7 minus 6, I push up 1 5 and I push down 1 1. Splitting motion. Split. Like this. 7 minus 6 is 1. Next, I have 6 minus 6. I set up 6 over here. 6 minus 6, basically split open like this. Again, minus 5 minus 1. So if I put them together, 6 minus 6 is 0. So on to addition. 6 plus 4. How do we do 6 plus 4? In this case, we need to use both our hands. 6 plus 4 is 10. Watch closely. 6 plus 4 is basically 6 plus 10 minus 6. So plus 10 minus 6. 6 plus 4 is 6 plus 10 minus 6. In one swift motion, like this. Okay. Same thing for 7 plus 3. I split it up and it becomes 10. 8 plus 2 and 9 plus 1. They all form 10. Next, I have 4 plus 6. 4 plus 6. Because 4 plus 6 is basically 4 plus 10 minus 4. So 4 plus 6. Like this. And then 3 plus 7. Over here I set up a 3. And after that, I use my left thumb and my right index to push it up like this. 3 plus 7 is 10. Lastly, 2 plus 8. And 1 plus 9 gives us 10 as well. Next, we have 5 plus 5. 5 plus 5 is a bit more special because it involves a 5 bit. 5 plus 5 is basically 5 plus 10 minus 5. With that, we can do one simple push like this, using our left thumb and the right index. 5 plus 5. 5 plus 5. Like this. So next we have 10 minus 9. 10 minus 9 is basically 10 minus 10 plus 1. I repeat, 10 minus 9 is 10 minus 10 plus 1. So in one swift motion, like this. 10 minus 8, like this. 10 minus 7, you get 3. 10 minus 6, I get 4. After that, I have 10 minus 5. 10 minus 5 is 10 minus 10 plus 5, which is 10 minus 10 plus 5, like this. 10 minus 10 plus 5. So I get a value of 5. 10 minus 4. 10 minus 4, I get 6. So notice how 10 minus 4 is 10 minus 10 and then plus 6 again. 10 minus 10 plus 6. 10 minus 10 plus 6. Next, I have 10 minus 3. 10 minus 3 is 10 minus 10 plus 7. 10 minus 10 plus 7, I get 7 over here. 10 minus 3 is 7. Next, I have 10 minus 2. 10 minus 2 is 10 minus 10 plus 8. So, minus 10 plus 8. I pinch the 8 together. Lastly, I have 10 minus 1, which is 10 minus 10 plus 9. 10 minus 10 plus 9. Like this. 10 minus 1 is 9. How about 10 minus 10? 10 minus 10, we use our left thumb over here. 10 minus 10, and I just flick it down with my left index finger. Last but not least, we have 0 plus 10. 0, this is our default position of the abacus. This is a value of 0 over here. So 0 plus 10, I can use either my left or my right thumb to just push a 1 over here in the tens column. And there we have 0 plus 10 gives us 10.